जी ईसा आपको ये विजिबल है स्क्रीन स्लाइड नंबर 1?
Yeah, yeah, yes, 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 sir.
ओके चलिए ठीक है. So let us start our today's lecture. This is our lecture number 14.1, in which we would be talking about the storage system. And storage system is an important part of our automated systems or automation, in which we carry out storage of the raw materials or the finished product. So we would be talking about the automated storage system, uh, and then we will be talking about the conventional storage system. So rather, first we will be talking about the conventional storage systems, and then subsequently we will be talking about the automated storage system. So what a storage system should provide us, it should be able to store the materials for a period of time and permit to access those materials when required. So this is the requirement of a storage system, and in fact, the automated storage system is termed as ASRS, which means Automated Storage and Retrieval System. So this is actually automated storage and retrieval system. So it means that it can store material for a particular period of time, and it can give us, or we can retrieve the stored material from the storage system whenever it is required. So this is what we are going to talk about today. So our lecture will comprise of two parts. Part one, which is 14.1, will give us we will be studying the storage system performance and location strategies. We will be talking about conventional storage methods and the equipment. We will be talking about the automated storage system, which is ASRS, Automated Storage and Retrieval System, and the analysis of size of automated storage system, which is a kind of rack system. So in part one, we would be doing all this, and in part two, we will be actually carrying out the analysis of throughput of the storage system. This is the auto ASRS. We would be calculating or analyzing its throughput, and we are going to also analyze the throughput of a carousel storage system. So we would study about these two topics in part two. So let us start with part one, which deals with the storage system, in which we will be studying conventional and the automated storage system. So the function of a storage system is to store materials. That is, these can be parts, these can be work in process. You must have realized or seen that we had introduced a terminology which was called work in process, which was used to store the raw materials or the finished product as well. So the function is to store the materials for a period of time and permit retrieval when required. This is used in factories, warehouses, distribution center, wholesale dealership, and some and retail stores. This is an important supply chain component, in which, according to the demands and supplies, you plan your storage. That how much material or how much finished items you need to store, and this will depend upon the demands and supply. Automation is available to improve its efficiency. So while we are talking about some automated systems or facilities, so in fact we can go with an automated storage system also. So this is actually improve efficiency, means that the increased production rate will improve the efficiency of the system. So what we need to do is that we want to make available our raw material right in time, and then we need to store our finished product to supply it to the customer in time and at a faster pace. So this is the um idea behind an automated storage and retrieval system, that is to increase the production rate, which will uh, in turn improve the efficiency of our system. The type of store materials which are stored by the manufacturer. So first we are going to talk about the materials which are related to the product. So these are the materials which are related to the product. So these are the raw materials. These can be purchased parts, work in process, finished product, rework and scrap. So parts which do not meet the specification, they need a rework or a scrap, and these are the rejected parts which can be used as a raw material for the next parts. Okay? So this is related to the product, and these are the stored materials. Yeah, these are the materials which are to be stored, which are related to the process, which are related to the process. So these are the refuse. Refuse is something which is which are the chips, swath, oil, or the waste product. So whenever you carry out a process, something like you are carrying out a process of turning, so it means that you are removing material from the from your raw material. So this will be in the form of chips or in the form of in the form of swath, which will be actually removed from the raw material to give it a shape. So this refuse will also to be collected and to be stored or disposed of, which requires some special precautions at some point of time. Secondly, the tooling. These are the toolings which are used in the manufacturing processes. So these can be some cutting tools, jigs, fixture, maybe some safety equipment like helmets and gloves. And then the spare parts, which are the critical parts. These parts are required to maintain and repair the factory equipment. So you need to have the spare parts of your machines also, so that the if any there is a if any malfunction or a failure occurs in a machine, so the spare parts can be used to repair it. So these are the materials which are related to the processes. All right. The office supplies, the types of materials which are stored by a manufacturer, they can be related to overall support. So these are related to the overall support of the factory operations, which include the office supplies, something like paper, some forms, some writing instruments, things like this. So these are the office supplies, and then the plant records, that whatever record you have of the plant, like its number of parts which have been manufactured, number of supplies given, the orders which have been received. So these all are to be stored by the manufacturer. So these are certain types of storages which I have just told you, that these are the different types of storages which are different types of materials which are required to be stored by the factory or the manufacturer. Alrighty, so we are now going to talk about the storage system performance. So if you read at the first line, so we are going to talk about the storage system performance, and just look at this line which I have written here is here. So actually this is enhancing the storage performance. This is what we have talked about earlier also, that we want to increase the performance of our facility, and that would actually the storage performance would be enhancing the performance of the storage system. So we are going to talk about these two things. So the performance measure of the storage system. So there are two measures. One, so we are going to how do we measure the performance of a storage system? So number one is the storage capacity, that how much storage capacity do we have, and then there are um, two measures to know or to measure the storage capacity, which can be in the form of total volumetric space. So this can be one measure to know the storage capacity, and the other could be the total number of storage compartments, and we will be considering that we will be storing unit load. We have already talked about unit load, so just a recap that the unit load is the one load in one compartment. So if I have two or three compartments with me, so one unit load will be put in one compartment. So this will be the storage capacity. Then the next is the storage density. The storage density is the volumetric space available for storage relative to the total volumetric space in the facility. So how much space you are utilizing for the storage in relation to your volumetric space of the facility. And the third part is the accessibility. So it's the capability to access any item in storage. So if you see the storage capacity and accessibility, they are related. If you look at this term or this line which is written, so high storage density will result in low accessibility. So what does that mean? It means that we have stored the materials at a place and they are stored in a very dense manner. So it means they are put very close to each other. So when they are very close to each other, so it will be difficult to access something which is, let's see, if I have a storeroom and there is one door only. So if I place something, let me just draw it here so that you can, let's see, if this is a room which has a door here. So what if I put start putting things from here, and then I put some of the things here which are closer to the door. So accessibility to these would be difficult. So this is how we need to know, or we need to make a strategy to store things in a way so that the things remain accessible to us. So we would be talking about it in a little while. Okay, then next, the fourth thing is the system throughput, and this is actually the hourly rate of storage or retrieval transactions, or we also call it as rate of transaction. We will define what is transaction in next to next slide. And then the fifth one is the reliability of the system. And we have already talked about this term reliability, which is a combination of utilization and availability. And we know about these two terminologies, which are called utilization and availability. All right, so let us move forward and now talk about the storage capacity. So this is the storage capacity, and we have discussed earlier the storage capacity is defined in terms of the number of loads which can be stored. So this is the storage capacity. Let us see that we have 9 storage compartments here. So the storage volume we have is 16 cubic feet. So this is one measure of storage capacity or storage performance, storage capacity in terms of storage volume. So this is 16 um, cubic feet. And then if I look at it in terms of number of storage compartments, so it has 9 storage compartments. So this is the compartment which I have drawn here. So this is going to store 9 unit loads for me. One, or in other words, I can say in another measure, I can say that this is the storage volume which I have, which is 16 cubic feet. So, have you understood these two terminologies, that the storage capacity in terms of volume and the storage capacity in terms of number of compartments? Is this understood? If it is, then we move forward. I did not receive any answer. Are you people online?
Yes, sir.
Okay, okay. So, okay, we have 8 people online. So I just thought that probably uh, I'm not audible. Okay, so we keep moving forward. I think as you people are listening to me, just one more thing which I want to add here. Um, a unit load can be something which will consist of only, let's see, one item, or maybe I can put number of items. If you look at this, so I can put number of items and make one packet. So this one packet, which is if I see here, so it seems that there are um, 8 and 8, 16 items in one packet. So this one packet is going to become 1 unit load, and we will be for this we will be using the terminology called pallet. So a pallet is something which is in which a number of items are packed together and made one packet or one item. So this is called pallet, and this will also be termed as a unit load, as we are talking about in terms of storage systems. Okay, so let us now define what is a transaction. We talked about it, that the um, storage performance is the hourly rate of transaction. So in 1 hour, how many transactions are carried out? So just look at this. Uh, okay, look at these two terms, place and pickup. So a transaction will be either a placement operation or a pickup operation. Okay? Then the storage performance will be measured according to two types of command cycles. Number one is the single command cycle, in which only one transaction takes place. मैं भी आपको इसको explain करता हूँ how. So a single command cycle would be a cycle in which only one transaction will take place. All right, and a dual command cycle would be a cycle in which two transactions will take place. So let me just explain you on this diagram, which is towards the right side of this um, slide. So this is our SR machine. SR machine is actually the storage and retrieval machine. So this is something, this is the SR machine actually, and this moves into the system, into the storage system, or either it places items or it picks up the items. So let me just follow the convention. So I have used a dot with a circle as a placement operation or a placement transaction, and a plus with a circle as a pickup operation. All right. So now let us see the two arrows which are here, which are green in color. So what happens? This is the single command cycle. So what happens? The SR machine will move on the will move as shown by the arrow, and it is going to place the item here and will come back to its original position. So this is the single command cycle which is shown in green. I repeat, this is the single command cycle in which only one operation of placement is carried out, in which the SR machine moves from the base, from this place to this place where it places an item and comes back. It can be vice versa, that it moves from here, from the base station as empty, and it picks up something from the same location and comes back. So the one transaction, either placement or pickup, is being carried out in a single command cycle. So let us now look at the dual command cycle in which two transactions are taking place. So a dual command cycle will have two transactions. So these two transactions will be, one of them would be placement and the other would be pickup. So now let us see, if you look at these black arrows, so you can see that this black arrow, um, the SR machine is loaded with a unit load and it moves, reaches here. So let me just take the black color. So it is, so the SR machine moves from the base station and reaches here and it places an item which was placed on it at this compartment. Then it does not come back actually. Then it moves forward and goes to this location and then picks up and then picks up another item from here and then comes back to its original location, which is the base. So now this is the black arrows. These show the dual command cycle in which two transactions, one is placement and the other is pickup, is being carried out in one movement of the SR machine. Okay, जी मुझे बताइए, are you people clear about the single command cycle and dual command cycle? So what you need to remember in these two command cycles, that one transaction is carried out in single command cycle and two transactions are carried out in dual command cycle. I am also again I am introducing another terminology which is called SKU, store keeping unit. So this is the each item type stored in a warehouse is known as SKU. It uniquely identifies the specific item. Let's see. यहाँ पे अगर आप देखें, SKU are the markers. Let's see, SKU1 are the markers and SKU2 are the pens. So ये जो pens and markers हैं, they will be called as SKU, store keeping unit. तो इनको नाम दिया जाता है और इसको store keeping unit जो है, they are the identification of the items which are stored. All right. We have talked about the storage performance in terms of transactions. ये तो हमें समझ आ गई कि ट्रांजैक्शन हमने करनी है. अब ये ट्रांजैक्शंस किस तरह से करनी है, तो वो that will depend upon the storage location strategy. So there are two types of storage location strategies. One is called the random storage. Okay. Number one is called the random storage and the second one is called dedicated storage. What does random storage means? The random storage means that the incoming items are stored in any available location. ठीक है? So ये अगर आप राइट साइड के ऊपर इस वक्त देखें, जो आपको एक डायग्राम नजर आ रही है, forget about A and B. For a moment, forget about A and B. Just look at the blue colors which are shown here with the help of cross and a tick. So whether you have an SKU A or an SKU B, it will be placed to the nearest location of the SR machine, nearest available location. So the crosses mean that this location is not available. So the nearest available location is this tick. So either you have A or you have B. You are going to place it here in the location where this tick is seen. So this is called randomized storage. So any item, any SKU, either SKU A or SKU B, so these are, and this will be placed according to the first available location. So this is called the randomized storage. The second one is dedicated storage. Now look at A and B. So what I have done here, if you can see that I had two SKU types, SKU A and SKU B. and I have marked a red region for SKU A and a green region for SKU B. So now the space for SKU A and SKU B, it is now dedicated storage. Okay? What happens now? In the dedicated storage, the incoming items are assigned to specific location in the storage capacity, in the storage facility, so not capacity, storage facility. So as I have done here as red and green colors. So what would be the basis of deciding the location? So the items stored in item number sequence. Item number sequence क्या है कि A SKU A है तो वो अपनी A लोकेशन में जाएगा, SKU B है तो वो अपनी B लोकेशन में जाएगा. ठीक है? Then items are stored according to the activity level. This is what I have to decide, that which item, which SKU, A or B, has a higher activity level, which has more frequent transactions. So if I look at this strategy which I have made here, so you can very well find out that SKU A has a larger or has a higher activity level, so that is why it is kept closer to the SR machine. I repeat, SKU A has a higher activity level, so that is why it is kept closer to the SR machine, and B has a lesser activity level, so then it is kept, or it is stored at a location which is at a more distance as compared to A. ठीक है? So ये ज़हन में हमने रखना है कि we need to वजह क्या है? वजह ये है कि we want to carry out our transaction in reduced number of, in less amount of time. So जो ज़्यादा transactions हैं, these will take lesser time, so our throughput of our storage system will increase. So इसलिए हम dedicated storage. अच्छा, अभी हम we will see कि random storage और dedicated storage में हमें किस में advantage है और किस में disadvantage है. इन दोनों के अपने अपने pros and cons, and we will study those also. So until here, I need an answer from you that have you understood the randomized storage and dedicated storage strategy or not? Somebody to please respond.
Yes, sir.
Okay, so if it is clear to you, so let us move forward. Let us move forward and see that how the storage locations and how we can see that the storage locations can help us in decision, or which has the advantage. Okay, so let us solve an example. Suppose that a total number of 50 SKUs. So these are the types of items which you are storing. So there are 50 types of items which you are storing, and these must be stored in a storage system. For each SKU, average ordered quantity is 100 cartons. ये और से इसको जरा सुनते जाइएगा और विजुअलाइज करते जाइएगा कि number one is that we have 50 SKUs which are to be stored. Each SKU has to be ordered in a quantity which is equal to 100, and average depletion rate of each SKU is 2 cartons per day. ठीक है? So 100 की क्वांटिटी में आपने ऑर्डर करना है, जब भी करना है. The depletion rate is 2 cartons per day. Okay, and the safety stock level is 10 cartons. What does this mean? It means that each SKU must have at least 10 cartons in your storage. Okay, so each carton required one storage location in the system. Okay, done. We know this, that unit load system hai. So based on this data, each SKU has an inventory cycle that lasts for 50 days. What does this mean? It means that if I order one SKU in 100 quantity, already maintaining a stock level of 10 cartons. So if I order 100 quantity at day 1, so in 50 days these 100 will deplete, and on 51st day I have to order it again. ठीक है. So this is the प्लीज अपने जहन में इस चीज को लेके आइए, एक पिक्चर बनाइए कि कैसे इनको मैंने डिमांड करना है. ओके. Since there are 50 SKUs in all, management has scheduled incoming orders so that different SKUs arrive at each day. देखिए एक साइकिल बना रहे हैं आप जो है. 10 का स्टॉक लेवल सबका है. डे 1 पे आप SKU 1 डिमांड करते हैं, 100 आ जाता है. डे 2 पे SKU 2, फिर 3, 4 और इस तरह आप करते जाते हैं. तो जब आप SKU 50 को डिमांड करते हैं ऑन द 50th डे, उस वक्त जो SKU 1 है वो डिप्लीट होके अपने 10 वाले लेवल पे आ जाता है, एंड देन इट इज डिमांडेड अगेन. सो 50 डेज साइकिल हो गया हर SKU का फॉर डिमांड.
सर ये थोड़ा रिपीट कर दें, ये सर
रिपीट
ज्यादा
कर दूं?
कंफ्यूज हो गए हैं.
ओके. सो रिपीट मैं करता हूं कि हर SKU का एक 50 डे का साइकिल हो गया. आपने डे 1 पे एक SKU डिमांड किया, नंबर 2 डे पे अनदर SKU, फिर SKU नंबर 3 आपने थर्ड डे पे डिमांड किया, और इस तरह करते करते यू वेंट अप टू SKU 50 ऑन 50th डे. सो 50th डे पे क्या होगा, जो SKU 1 है जो आपने 100 डिमांड किया था, वो 2 कार्टन्स पर डे के हिसाब से डिप्लीट होता होता अपने मिनिमम स्टॉक लेवल पे आ गया. तो आप 51st डे पे फिर डिमांड कर देंगे SKU 1. सो ये हर साइकिल, हर SKU का एक 50 डे का साइकिल जो है वो आएगा. ठीक है, ये बात अंडरस्टूड हो गई?
यस सर.
Okay, so what we need to determine the number of storage locations required in the system under 2 alternate strategies, randomized storage and dedicated storage. अब देखते हैं कि इसका क्या एडवांटेज है. सो यही जो बात मैंने आपको पहले बताई कि डिमांड कैसे है, तो वो मैं आपको यहाँ पे जरा एक दफा ड्रॉ करके दिखा देता हूँ. सो लेट अस सी कि ये एक जो इस वक्त आपको नजर आ रहा है 50 डे का साइकिल है. लेट्स सी, इस ब्लैक को मैं कहता हूं कि दिस इज SKU 1. सो दिस इज इट्स मिनिमम स्टॉक लेवल. ये देखें, ये 10 वाला इज योर मिनिमम स्टॉक लेवल. इसका जो जब भी आप 100 डिमांड करेंगे तो इसका जो मैक्सिमम स्टॉक लेवल है दैट विल रीच टू 110, एंड 60 वुड बी इट्स एवरेज स्टॉक लेवल, जो कि एवरेज इन्वेंट्री लेवल. सो दिस इज द सेफ्टी स्टॉक लेवल, average level, and this is the max stock level. अब सिर्फ अब यहां से देखिए, लेट्स सी, यहां पे इसको ऑर्डर किया गया था. मैं इसको कहता हूं कि दिस इज डे विच इज कॉल्ड D. सो D डे के ऊपर SKU 1 was demanded. सो SKU 1 का लेवल रोज अप टू 110. Then it started depleting 2 cartons per day, and it came down. So D plus 50. तो फर्स्ट डे पे अगर वो 110 था तो D plus 50 डे के ऊपर वो डिप्लीट होता होता क्या हो गया, दोबारा 10 पे आ गया. नाउ एट D plus 51 it will be demanded again. ये बात समझ आ गई?
यस सर.
ओके. सो अब आप देखिए, मैं आपको एक और यहाँ पे बना के दिखाता हूँ. लेट्स सी, देयर इज अनदर SKU जो कि D-1 डे पे डिमांड किया गया था. सो आप देखें, ये ब्लू कलर में मैं बना रहा हूँ. यहाँ पे, यहाँ से ये ऐसे it will deplete like this, ऐसे it will be demanded again, it will deplete like this. So ये क्या हो रहा है, ये एक दिन पहले D-1 डे के ऊपर. सो द ब्लू वन इज SKU, लेट्स सी, मैं इसको SKU 2 का नाम दे देता हूँ. इसी तरह एक और मैं आपके लिए ड्रॉ करता हूँ विच इज SKU 3, जो कि मैं कहता हूं कि वो इस जगह पे डिमांड होता है, which is D+1. So this will be something, this will be its cycle, 50 days cycle would be something like this. ठीक है, तो ये आपको 50 डेज का साइकिल SKU1, SKU2 और SKU3 का नजर आ गया। ये वो बात है जो मैं आपको पिछले उस पे आई वाज ट्राइंग टू एक्सप्लेन कि कैसे ये डिमांड्स होंगी। अब ये डिमांड्स की तो हमें समझ आ गई। दिस इज द स्ट्रेटजी व्हिच द मैनेजमेंट हैज मेड। सो नाउ वी नीड टू सी दैट हाउ मच स्टोरेज capacity we would require if we go with the random storage or we go with the dedicated storage. So let us see here. So the maximum inventory level is 110. We know this. Okay. The minimum is 10. The average is 60 cartons. So each SKU, if I talk about the randomized storage, each SKU is equal to the average inventory level. So total space required as an average in a randomized storage stuff. So I have 50 SKU and 60 is the average level. So I would require only 30 locations, 3000 location to store if I go with the randomized storage. ठीक है, ये इंट्यूटिवनेस से ये बात समझ आ रही है? So 60 carton is the average of each SKU, or 50 SKUs there, and so I need 3000 locations. Now come over to the dedicated storage. So if I want to have a dedicated storage, to every SKU, I need to have maximum number. I need to have a location or a storage location which according to the maximum number of items I want to store, maximum number of quantity I want to store. So each SKU will have max of 110 units. ठीक है, so 110 units जो है वो मुझे, या 110 storage location मुझे every SKU के लिए चाहिए, which comes to the storage locations equal to 5500. So it means that for a dedicated storage, I would always require more amount or more space or more number of compartments for a dedicated storage strategy, and for the randomized storage strategy the space required would be less. So ये आपको एक dedicated और randomized storage की एक calculation भी आपके सामने यहाँ पे आ गई. Okay, so let us move forward and now talk about the comparison. Important चीज, this is important. ठीक है, हमने दो strategies देख ली. So how do we compare these? So let us see. So number one, less storage, less total space is required in a storage system that use a randomized storage strategy. और उसके contrary क्या है कि dedicated storage requires space for maximum inventory level of each item. ये उसका contrary argument है. Second क्या है? Higher throughput rates are achieved in a system that uses dedicated storage strategy based on activity level. We have talked about it earlier, that since we know that where our item is placed, so we will go into that and then we will keep the maximum activity level closer to the SR machine, so more transactions are carried out into that area where we have an item which has a higher activity level. So the most active item can be located near input and output point, which is SR machine. Compromise क्या होगा? Class based dedicated storage है, ठीक है? So class based dedicated storage है, it will have a higher throughput rate, but it will take more space. So the items are divided into classes according to activity level. We have talked about it, and within the just look at this sentence that random storage strategy used within each class. So whatever dedicated space is available to us for a certain SKU, so within that dedicated space, random storage would be used, and random only for one type of SKU. So the SKU coming into a dedicated storage space will be placed on the first लोकेशन विच इज एम्प्टी, जो कि हमारी रैंडमाइज स्टोरेज की एक स्ट्रेटजी थी. ठीक है, सो दिस इज द कंपैरिजन. सो लेस स्पेस इज रिक्वायर्ड फॉर if we go for randomized storage, more required for dedicated storage, higher throughput for dedicated storage and reduced throughput for the randomized storage. So ये comparison है आपकी strategy का. It will depend that आपके पास space कितनी है and then आप किस तरह का throughput चाहते हैं. तो इसके ऊपर you can decide that whether you go with the randomized storage strategy or with the dedicated storage. जी मुझे बताइए, यहां तक आपको ये क्लैरिटी है?
Yes, sir.
Okay, so let us move forward and talk about some conventional methods. So bulk storage in an open area. Problem क्या है? Achieving proper balance between storage density and accessibility. ये देखिए, ये वही वाली डायग्राम यहाँ पे आपको फिर नजर आ रही है कि एक कमरा है जिसके अंदर this is the door and you are placing something here in this corner, so you will have a problem in accessibility. Then rack system, structure with racks for pallet loads. This permit vertical stacking of the materials. Accessibility increase हो जाती है. If you look at my hand, so this will be actually stored in like this in a vertical fashion. So अगर आप ये बड़े-बड़े metro stores और इस पे जाएं तो you can see कि आपके जो items हैं, they are stored in vertically, they are stored in racks. Then shelves and bins. These are the horizontal platform in a structural frame. So आपके पास एक shelf है जो कि horizontal बनी हुई है और उसके ऊपर आप इस तरह से अपने items रख देते हैं. ठीक है. Then drawer storage, कि आप अपने drawer जो है उसके अंदर store कर लेते हैं. ड्रॉर की मैं एग्जांपल हमेशा देता होता हूँ कि हम अपने ड्रॉर्स में क्या करते हैं कि ड्रॉर खोलते हैं, उसके अंदर अपनी चीज़ें, रुमाल रख दिया, वेस्ट रख दी, जुराबें रख दी और इकट्ठे एक दूसरे को बढ़ा दें. अब जब हमें जुराबें ढूंढनी है तो हम अपने ड्रॉर खोलते हैं, ड्रॉर को उलटते हैं पूरे को और उसमें से फिर हम जुराबें निकाल के दोबारा बाकी सारी चीज़ें उसमें डाल देते हैं. ऐसे ही होता है. तो अगर हम उस ड्रॉर में खाने बना लें, उस ड्रॉर में वी मेक कंपार्टमेंट्स एंड वी से कि इस कंपार्टमेंट के अंदर जो है वो सॉक्स होंगी, इस कंपार्टमेंट के अंदर वेस्ट होगी, इसके अंदर मेरा हैंडकरचीफ होगा. सो अब जब मैं ड्रॉर खोलूंगा तो आई विल हैव एक्सेस टू ऑल द आइटम्स व्हिच आर प्लेस्ड इन द ड्रॉर. सो दिस इज हाउ ड्रॉर स्टोरेज शुड बी. सो ये देखिए, ये बल्क स्टोरेज आपको नजर आ रहा है. सो आप देखिए, ये पहला अगर आप जो ए डायग्राम देखें तो इसके अंदर आई कैन नॉट एक्सेस द सेंटर. बल्क स्टोरेज को मैं इस तरीके से बेहतर बना सकता हूँ कि आई कीप अ वे इन बिटवीन, सो आई कैन एक्सेस द आइटम्स व्हिच आर मार्क्ड रेड. आई कैन एक्सेस देम इजीली. So the bulk storage जो है is something look like this, but it can be stored in a fashion which can increase the accessibility. ये pallets हैं, आप इनको देख सकते हैं. Pallets and rack system है. So vertical storage आपको नजर आ रहा है. So इसके अंदर आप जो हमने बात की थी ये वही आपको यहाँ पे नजर आ रहे हैं. Then ये आपके shelves and bins हैं. इनकी भी अगर आप compartments कर लेते हैं तो किसी में मार्कर रख लिया, पेन रख लिया तो इजीली आप इसको कर. बट देन यू हैव टू मार्क देम. If you do not mark them, then you would not remember that where are your pens and where are your markers placed. And this is the drawer storage. So you need to divide your drawer into partition, and you can put item number 1, 2, 3, 4 in the dedicated compartment. So this is the drawer storage. So ये conventional storage के कुछ आपको यहाँ पे मैंने दिखाए. अच्छा, ये एडवांटेजेस एंड डिसएडवांटेजेस हैं इन्हीं कन्वेंशनल स्टोरेजेस के, जो कि हमने बात भी कर ली आपस में, एंड देन यू कैन रीड देम आउट फ्रॉम दिस स्लाइड के बल्क स्टोरेज के एडवांटेजेस, डिसएडवांटेज और इन तमाम के व्हाट आर द एडवांटेजेस एंड डिसएडवांटेजेस।
सर
जी
सर, इसमें ऑटोमेशन कहाँ से आएगी?
अभी नहीं आई, ये कन्वेंशनल था। आपने
यानी
ऑटोमेशन जो मैंने आपको एसआर मशीन दिखाई थी, दैट वाज ऑटोमेटेड।
सही।
जो मैंने आपको एसआर मशीन दिखाई थी वो ऑटोमेटेड है। अभी हम उसी की तरफ जा रहे हैं। अब इफ यू लुक एट दी स्लाइड नंबर 22, सो आप ये देखिए ये ऑटोमेटेड स्टोरेज की हम बात करने लगे हैं। ऑटोमेटेड स्टोरेज क्या है? वी नीड टू हैव मैकेनाइज्ड एंड ऑटोमेटेड स्टोरेज इक्विपमेंट टू रिड्यूस द ह्यूमन रिसोर्स। ठीक है, इसके साथ आपके पास ये चीजें आपके पास आएंगी। नंबर 1 कि आपको एक सिग्निफिकेंट इन्वेस्टमेंट की जरूरत है, और नंबर 2 आपने डिसीजन करना है कि व्हाट लेवल ऑफ ऑटोमेशन यू वांट टू अचीव। So in mechanized system, an operator participates in each storage and retrieval transaction. Something like forklifter, जिसका operator है. So forklifter is an automated storage. You don't have to pick up things by yourself. You just drive a forklifter, pick up the stuff and place it at any place. So in this system, mechanized system, में you will have an operator. In highly automated system, ये जो आपको यहाँ नजर आ रहा है, highly automated system, loads are entered or retrieved under computer control. So there is no requirement of operator. So it is done through computer according to जो कि हमने देखा था single command cycle and dual command cycle. ठीक है, तो हमने एक automated storage की पहले बात की, फिर हमने conventional storage की बात की, इन दोनों को हमने देखा। अब हम automated storage system की तरफ जा रहे हैं कि वो कौन कौन सी चीजें हो सकती हैं। तो these can be mechanized systems or automated storage equipment. सो मैकेनाइज्ड सिस्टम में ऑपरेटर आएगा, ऑटोमेटेड स्टोरेज में जो कि हाईली ऑटोमेटेड सिस्टम्स हैं उनके अंदर आपको जो इन्वॉल्वमेंट ऑफ द ह्यूमन इज नॉट देयर, यू विल बी यूजिंग द कंप्यूटर कंट्रोल। जी अभी कुछ थोड़ा सा आपको समझ आई कि हम ऑटोमेशन की तरफ कैसे जा रहे हैं?
यस सर।
ओके, दैट्स ग्रेट। सो ऑटोमेटेड स्टोरेज सिस्टम जो है वो किस लिए यूज किए जाते हैं, ऑब्जेक्टिव्स क्या है, ये आपको ऑब्जेक्टिव्स यहाँ पे नजर आ रहे हैं। 1, इंक्रीज स्टोरेज कैपेसिटी, इंक्रीज स्टोरेज डेंसिटी, डेंसिटी इंक्रीज करें बट उसके साथ साथ एक्सेसिबिलिटी भी इंक्रीज हो रही है। सो ऑटोमेटेड स्टोरेजेस जो है वो आपको ये चीजें प्रोवाइड करते हैं। सबसे इंपॉर्टेंट इज द लास्ट वन, जो कि विच इज टू इंक्रीज द थ्रूपुट, which is the hourly rate of transaction. हमने ट्रांजैक्शन डिफाइन की थी, हमने सिंगल डुअल कमांड साइकिल्स डिफाइन किए थे, और हमने बात की थी कि ये थ्रूपुट जो है वो आवरली रेट ऑफ ट्रांजैक्शंस है। सो दिस इज इसकी जो मैथमेटिकल कैलकुलेशन है वो हम अभी सेकंड पार्ट ऑफ दिस लेक्चर जो आज हम पढ़ रहे हैं इसके सेकंड पार्ट में हम उसकी बात करेंगे। ठीक है, अब आ जाए ऑटोमेटेड स्टोरेज एंड रिट्रीवल सिस्टम। अभी मैं थ्रूपुट की बात नहीं करूंगा, अभी यहाँ पे मैं सिर्फ इसकी बात करूंगा कि साइजिंग आपने कैसे करनी है। दिस इज नॉट वेरी इंपॉर्टेंट। अभी आई एम गोइंग टू टॉक अबाउट ओनली द साइजिंग ऑफ द ASRS। Sizing, what do I mean by sizing? That if I want to store something or store item of certain dimension and I want to store it in a certain number, तो साइजिंग कैसे होगी। सो अभी इस पार्ट में मैं आपको साइजिंग दिखाने लगा। सो प्लीज स्टे विद मी, थोड़ा सा जरा ज़हन में रखिएगा कि ये कैसे मैं आपको दिखाना चाहूँ। जस्ट लुक एट दिस डायग्राम जी। नंबर 1, पहले तो इस डायग्राम को देखें। आपको ये 3 डायमेंशनल इसका व्यू नजर आ रहा है, और आपको ये नजर आ रहा है कि ये 2 ऐसे रैक्स के पिलर्स हैं, 2 रैक्स हैं, और इन दोनों के दरमियान देयर इज अ स्पेस जो इस एरो से आपको नजर आ रही है, और इस स्पेस के बीच में ये आपका एक SR मशीन लगी हुई है। सो एक रेलिंग है जो कि आपको ये नजर आ रही है, ये इस तरह से इसके ऊपर यूं भी मूव करती है SR मशीन, और ये जो रेलिंग अंदर की तरफ जा रही है इसके ऊपर यूं भी मूव करती है। जहां पे आपको देखिए काइंडली, जहां पे आपको ये समझ आए कि यार आपको ये कंस्ट्रक्शन समझ नहीं आ रही तो प्लीज मुझे बताइएगा, ठीक है। सो ये दो रैक्स हैं। सो ये इफ दिस इज माय आई, दिस इज माय आई, एंड आई लुक एट this system from here, so this is going to look like this, कि ये दो आपको रैक्स के टावर नजर आएंगे, इनके दरमियान में एक स्पेस नजर आएगी, this space is called aisle. I repeat, the space between two racks is called aisle. और इस aisle के अंदर आपकी जो SR मशीन है वो चल रही होगी। So इसका मतलब क्या होगा
सर? ये आयल ए से ही आई से?
AISLE, let me just write it down, मेरा ख्याल है पहले मैंने बहुत ही गलत, AISLE। ये जैसे आपकी आप एयरक्राफ्ट में बैठे, जहाज में बैठे, तो सीट्स के दरमियान आपका आयल होती है, और उस जो जिसके ऊपर लोग मूव कर रहे होते हैं, और उसके साथ वाली एक आपकी विंडो सीट होती है और एक आयल सीट होती है, ये वो आयल है, ठीक है?
ठीक है सर।
अंडरस्टूड?
यस सर।
Okay, so if I look at here, जहाँ पे मैंने I बनाई है, if I look at from this side, so I would see two towers with an aisle in between, and the aisle would have the SR machine. So let us see here. अब दोबारा इस 3D वाले पे आ जाए. So this is rack number 1. This is rack number 2. ठीक है? So the rack has a length equal to L. The rack has a height equal to H. And the width of the racks including aisle would be W. ये मैं आप कुछ टर्म्स इंट्रोड्यूस कर रहा हूँ, अब हमने इसको यूज करना है। ये जो सिस्टम which you are looking at on the slide is called one aisle system. This is called one aisle system, and it has two racks. ठीक है? और मैंने इसको L, H, W इन तीन चीजों को मैंने डिफाइन कर दिया। ओके, अब मैं इसको अगले उस पर जाऊंगा। Okay, now this is the side view which is underneath, which is here. This is the side view in which you can see L and H dimension, and this is the top view in which you can see the W dimension. What we are doing it at the moment, we are calculating the size of the ASRS. And what are our assumptions? Our assumptions are that only a unit load will be put in one compartment. So one unit in one compartment. तो हम अपने साइजिंग करने लगे हैं ASRS। ओके, अब यहाँ आ जाए। आयल आपने यहाँ देख लिया। This is the pathway between storage compartments. P&D station is the pick and drop station. W is the width of the aisle. ये आपको W नजर आ रहा है. L is the length of the aisle, which you can see here. H is the height of the ASRS, which is H. ठीक है? Now NY, number of compartments in horizontal direction. So देखिए ये मैंने रेड से 1 2 3 4 5 6 7 8 9 लिखा। So I have 9 compartments in horizontal direction. ये आपको लिखा हुआ नजर आ रहा है। Then NZ are the number of compartments in vertical direction. Again ये green से लिखा हुआ नजर आ रहा है 1 2 3 4 5 6. So we have 6 number of compartments in the vertical direction. So total storage capacity मेरी कितनी हो गई? NY into NZ in one rack. So this is NY into NZ, one rack multiplied by 2, because this is a 2 rack system. This is one aisle system which has 2 racks. So I'm going to have a capacity, a storage capacity of 108 compartments, जो कि 9 cross 6, 54 cross 2, 108. So this is one aisle 2 rack system which has one SR machine, and if I have 9 compartments in horizontal direction and 6 compartments in vertical direction, so I'm going to have the compartments equal to 108. यहाँ तक तो कोई प्रॉब्लम नहीं है. अब आपको एक समझ भी आ गई कि ओरिएंटेशन भी सही हो गई और आप कैपेसिटी भी निकाल सकते हैं. अब आ जाए इसकी डायमेंशंस के ऊपर, साइजिंग की जो बात की. नंबर ऑफ कंपार्टमेंट्स तो एक चीज होगी, अब इसकी साइजिंग कैसे करनी है, अब हम उसकी तरफ आते हैं. अब जरा थोड़ा सा गौर से आपने मेरे साथ रहना है. लेट अस सी x, y and z are the width, height of the unit load, depth, width and height of the unit load, x, y and z. So ये मैंने एक unit load बना दिया. I have made a unit load, ये आपको यहाँ नजर आ रहा है, which has 3 dimensions x, y and z. What is important to know that we must have a larger compartment size than XYZ. Understood? बिल्कुल कोई इसके अंदर शक नहीं है कि if we do not have a compartment which is larger than X, Y and Z dimensions, so our SKU or our unit load is not going to fit in that condition. We're not going to fit in that compartment. So we need to have a compartment which is larger than the dimensions X, Y and Z. ओके. अब कितना लार्जर होना चाहिए? सो वी नीड टू गिव एन अलाउंस. ये जरा गौर से देखिए इस वाली टर्म को. A, B and C are the allowances given in design of each compartment. आप पे डिपेंड करता है. Let's see, आप कहते हैं कि X जो है वो 10 इंचेस था, तो मैं X के अंदर अलाउंस 1 इंच का रख लेता हूँ, डिपेंडिंग अपॉन कि मेरा जो स्टोरेज सिस्टम है वो कितना प्रिसाइज है, कितनी प्रिसीजन के साथ चीज़ों को प्लेस कर सकते हैं. सो मैं एक अभी बिल्कुल आर्बिट्रेरी वैल्यू की बात करूंगा which is ABC. So I am associating, गौर से देखिएगा, I am associating A as an allowance with X, B as an allowance with Y and C as an allowance with Z. Okay, good enough. Now I am associating Y dimension of my SKU or a unit load with L. यानी जिस डायरेक्शन में मेरा L चल रहा है या जिस डायरेक्शन में मेरा लेंथ L चल रहा है, उसी डायरेक्शन को मैं कहता हूं कि वो मेरी Y वाली जो डायमेंशन है वो इस डायरेक्शन में आएगी. ओके, सो आई एम एसोसिएटिंग Y with L, Z with H and X with W. जी, यहां तक आपको बिल्कुल बात समझ आई कि नहीं? कोई स्टूडेंट जिसको ये बात समझ ना आई हो कि मैंने ये एक्स वाई जी को पहले ए बी सी से अलाइन किया, एसोसिएट किया, और फिर इस एक्स वाई और जी को मैंने एल एच और डब्ल्यू के साथ भी एसोसिएट कर दिया. ओके, if everybody has understood this, so let us move forward and calculate that how much will be the total length of my system, जो कि ये नजर आ रही है L. So definitely Y, एक कंपार्टमेंट में जो मैं चीज रख रहा हूं उसका साइज Y है, उसके साथ एसोसिएट किया मैंने B, और जितने नंबर ऑफ कंपार्टमेंट्स में बनाना चाहता हूं उनसे मल्टीप्लाई कर दूं तो आई एम गोइंग टू कैलकुलेट या आई कैन कैलकुलेट द टोटल लेंथ L ऑफ माय सिस्टम. कोई इशू नहीं है. सिमिलरली Z डायरेक्शन में, H direction में, I have Z as the dimension of my unit load, allowance headed as C, which is associated with Z, multiplied by number of compartment in z direction, h direction. Multiplying this is going to give me h. तो मेरे पास L dimension भी आ गई, H dimension भी आ गई. Now only the width is left. So width में देखिए कि I have width के लिए मैंने x रखा था. A was associated as an allowance with x, and why this 3 has come in. So look at this here. So this dimension would be x plus a. ये देखिए. Another दूसरा जो आपका रैक है उसमें this dimension would be x plus a. अब आप ये देखिए कि इस आयल की डायमेंशन भी
सर आयल को इतना क्यों बड़ा कर दिया?
जी सॉरी
सर आयल को फिर बड़ा कर दिया.
आयल
की एक ही हमेशा विड्थ नहीं रहनी चाहिए.
नहीं तो आयल की विड्थ तो एक ही है. आयल की विड्थ देखें तो x प्लस a है. ये देखें, अगर ये देखें, ये नंबर 3 देखें, दिस इज आयल विड्थ.
ये सर यही कह रहा हूँ सर, अगर हमारा x प्लस a काफी बड़ा हुआ और आयल को इतना बड़ा होने की जरूरत तो नहीं होती सर.
नहीं देखो, इसने आयल के बीच में से मूव करना है.
ओके सर, ओके समझ गया.
आया समझ?
यस सर, नीचे भी आना है उसने.
हाँ, इसने नीचे भी आना है. सो आयल हैज टू हैव a width or a dimension in which the SKU can move easily. So इसलिए इसको आप देखें, ये थर्ड आ गया. तो ये जो 3x plus a है, इनको जब मैं आपस में ऐड करूंगा, so this will become 3x plus a. So this is how I can calculate the length, height and width of my ASRS. Clarity हो गई जी इसमें? Okay.
Yes,
so
sir.
let's move forward and solve an example. Sizing pair. लिख देखिए. Each aisle of a 4 aisle system. तो 4 aisle हो गए. ASRS to contain 60 storage compartments in length direction. So NY is 60. And 12 compartments vertically. So NZ is 12. All storage compartments will be of same size to accommodate standard pallets of dimension x, y. आ गया x, y और z. ये तीनों आ गई देखें. x, y and z. Using the allowance भी आ गया a, b and c. Determine how many unit loads can be stored and also calculate the width, length and height of the ASRS. तो सिंपल है. ये देखिए ny NZ ये दोनों आपके पास मौजूद है, 60 and 12. ये यूनिट लोड की डायमेंशन आपके पास मौजूद है x, y और z की. ये अलाउंस आपके पास मौजूद है ABC. सो नंबर ऑफ कंपार्टमेंट्स, आप 1 आइल की कैपेसिटी निकालेंगे 2 into NY and NZ. सो ये 40 कंपार्टमेंट्स आ गए. एंड सिंस वी हैव 4 आइल सिस्टम, याद रखिएगा, so we multiply it by 4 and we have 5760 compartments. और ये देखिए, ये 4 आइल सिस्टम आपको नजर कैसे आएगा. ये देखिए, this is aisle number 1, this is aisle number 1. तो इसके एक तरफ कंपार्टमेंट्स आ गए, दूसरी तरफ कंपार्टमेंट्स आ गए. और ये देखिए, ये दोनों कंपार्टमेंट्स बैक टू बैक जुड़े हुए हैं एक दूसरे से. लेकिन इस वाले कंपार्टमेंट को आइल नंबर 2 से आपको एक्सेस मिलेगी. देखिए, जैसे आइल नंबर 1 से आपको 1A और 1B में एक्सेस है, इसी तरह आइल नंबर 2 से आपको 2A और 2B में एक्सेस मिलेगी. 3 की 3A 3B और 4 की 4A 4B. ये टॉप का व्यू है. तो ये आपको 4 आइल सिस्टम इस तरह से नजर आएगा. नाउ L, इसकी लेंथ, हाइट और विड्थ निकालने के लिए हमारे पास ये सारा मौजूद है. ये इंचेस, तो ये 280 फीट. कोई फॉर्मूला जो मैंने वहां देखा था कि NY Y प्लस B में, सो 280 फीट है. ये Z है, H है, 46 फीट आ जाएगा. W इज 12 फीट. ठीक है. और देखिए, ये 1 आइल है, ये ज़हन में रखिएगा, ये 1 आइल है. तो सिर्फ W की डायरेक्शन में इसकी विड्थ बढ़ रही है, बाकी L और H इसका वही रह रहा है. सो आप ये देखिए कि L इसका देखें, जो मेरा टोटल सिस्टम जो स्पेस ऑक्यूपाई करेगा, दैट विल बी L is 250 feet, 280 feet, H is 46 feet, and W is 48 feet because this is a 4-aisle system. So ये 4-aisle system जो है इसके साथ मल्टीप्लाई करके तो ये 48 फीट का आपके पास. So number of compartments आपके पास जो थे उनके मुताबिक you have calculated that how much space you would require to accommodate these number of unit loads into your compartments. ठीक है जी, यहां तक क्लियर? सिंपल है, सिर्फ एक दफा आपको अगर विजुअलाइज हो जाए कि आप क्या करने जा रहे हो, सो दिस वुड बी वेरी इजी, लेकिन इसकी विजुअलाइजेशन इज इंपॉर्टेंट. ठीक है जी. सो वी टेक अ ब्रेक ऑफ 5 मिनट्स और हम फिर पार्ट 2 जो है वो 5 मिनट्स के बाद शुरू करते हैं. एनी क्वेश्चंस अंटिल
एक दिन में काफी हो नहीं गया सर, इतना कॉन्सेंट्रेटेड पढ़ा रहे हैं.
फिर आपको अगला वीक लगाना पड़ेगा मेरे साथ.
ओके सर, ये फिर आज कल का फिर आखिरी पीरियड होगा अगर आज ये,
अगर आप ये कर लेते हैं तो हम बस फिर अगले वीक में वी विल ओनली हैव रिवीजन.
ओके सर.
देख लें, डिसाइड कर लें. आई डोंट नो बाकी लोगों के क्या व्यूज हैं. अगले वीक में क्लास कर लेंगे. कुछ रिवीजन की, कुछ लोगों ने मुझे कहा हुआ है कि उनको कुछ चीजें नहीं, दे नीड अ रीइंफोर्समेंट, तो वो फिर हम वो वाला टॉपिक अगले वीक में कर लेंगे और उसमें यही होगा कि जो इंटरेस्टेड है वो आपको अटेंड कर ले और जिसको समझ नहीं है, वो समझता है कि मुझे आता है, तो वो बेशक अगले. फिर आपके पास अभी आपके पास 2 वीक्स है ना आगे इसके बाद. जी, इस वीक के बाद 2 वीक है.
सर ये यस सर, मे बी